In numbers 10 and 11, instead of expanding the logs, we're going to write the expressions as a single log. So we're going to just reverse the process that we just used in problem numbers 8 and 9. So notice that we have the difference of logs, but we actually need to make sure we are careful here. We don't want to use the property of the difference of logs until we get the logs, until each of the log expressions has a 1 in front of them. And so we're going to use that power property, log base 10 of 5 minus, we're going to move the k, we're going to move that coefficient to the exponent position. Therefore, what we do is we free up the logs to now use that log property, the subtraction property that says if we have the difference of logs, that means that we have the log of a quotient. So we have log base 10 of 5 over 2 to the k, and that's it. So basically you are reversing the steps that you used when you expanded the logs. Now we're condensing the logs. So you either have expansion or whatever that term is, condensing or expanding. And then number 11, well, like we just did in the last problem number 9, scoot that on down. Problem number 9, we have a number on the outside. Well, we're going to have to combine the insides first and then combine the logs here, first using the property. Sum of the logs is the log of a product. So we're going to do that first. Log base, not base 4, log base b of 4 times x. And then we also have this over here, log base b, 3 times log base b of y. Well, now that we have the 1/4 in front of the log, we can move that again to the exponent position. But be really careful here. The log base b of the entire argument, which is 4x, being raised to the 1/4 power. So you have to be, like I said, you have to be careful about that. Don't just raise the x to the 1/4. Make sure you put parentheses around the 4x. And then we're also going to move this coefficient to the exponent position and write this as log base b of y to the 3rd. And so now we have the logs with coefficients of 1. And we have the difference of logs, and so we can go ahead and use that property. The difference of the logs is the log of the quotient. So we take the log base b of the first one, which is 4x, all of that raised to the 1/4, over y to the 3rd. And that's it. We condensed the log, or we wrote the expression as a single logarithm. Okay. And then down here to number 12 through 14, we're solving log equations. I'm going to try to squeeze all this in so we can see everything here. This is a really good example. You can see the two different types of exponential equations. Let's look at them both here before we get started. Number 12, we can see that both the bases, 27 and 81, can be written as powers of 3. So we're going to do that. And then the other strategy here for number 13, we can't express both sides, both bases, as a power of the same number. 130 is not a power of 5. So we have to use logs for this one over here, but we don't need to use logs when we can express both sides or both bases as a power of 3. So here's how we do that. 27 can be written as 3 to the 3rd. 81 is written as 3 to the 4th. So now we have the same bases on both sides. Let's go ahead and use the property of exponents here. Power to a power, we multiply. 3 times 3x is 9x. And on the right side, well, we can't simplify that 4 anymore, so we have 3 to the 9x equals 3 to the 4th. And which means that since the bases are the same, we equate the exponents. 9x equals 4. And when we divide both sides by 9, we get x equals 4 over 9. So that's one way to solve exponential equations. It's good to recognize when you're going to do, when you don't need logs, and then over here when you do need logs. So let's rewrite this with a little bit more space so you can see what's going to happen here. A couple different ways to do this, but the way we've talked about really is, let me get a green pen, noticing that we have a base of 5, and over here we have a number that can't be expressed as a power of 5. So we're going to take the log base 5 of both sides. And when we take the log base 5 of 5 to the anything, it's as if these cancel each other out, which they actually do. The property of exponents allows you to cancel those out. And log base 5 of anything is the anything. And so we get 2x on the left side. And on the right side, we get log base 5 of 130. Well, anytime we have 2 times a number equaling something, we can just divide both sides by 2, and then we free up the x, and so we get x equals the log base 5 of 130 all over 2. There are other ways to write that, but that right there is a valid expression, and that's what x is equal to, and so we're going to go with that. Now, for number 14, you know what, I'm going to pick up number 14 in the next video, because then I can do the second page as well.